Hey everyone, today we'll be doing a lesson on solving fractions. I didn't really know what to name this, so this is what I named it. Anyway, an example would be like this question we have here, where you're basically adding two fractions, but people find it confusing anytime there's an x involved. So, I want to start, before we do this question, by adding basic fractions, okay? So, if you have 5 over 7 plus 4 over 3, what do you need to do? Well, the problem here is that they don't have the same denominators, which means you will have to make them the same denominator so that you can add the numerators, right? So essentially what you do is 5 over 7 times 3 over 3, because remember 3 over 3 is just 1, so this is fine. Like this is the equal to what we just have here, right? And then plus 4 over 3 times 7 over 7. Once again, 7 over 7 is 1, so this is equal to this. Now, that makes 15 over 21 plus 28 over 21. So now you can see both the denominators are the same, which means that now I can add the top number, the numerator. 15 plus 28 is 30, is it 33? No, it's, my bad. 43 over 21, and that's how you would be able to solve it, okay? So now using the same logic, we're going to use that logic on any time there x is involved as well. So, for example, if I was to give you 5 over x minus 3 plus 6x minus 3 over x plus 2, you would try to do it so that the denominator is equal, and as you can tell here, I multiplied this 7 with 3 over 3. So I'm going to do the same process here. 5 over x minus 3 times x plus 2 over x plus 2. I'm just going to change this to 6 for simplicity's sake. And then 6 over x plus 2 times x minus 3 over x minus 3. So when you do this, basically what you're trying to do is when you multiply these two things together, the denominator is now the same. So you would get here 5 times x plus 2 over x minus 3 times x plus 2 plus 6 times x minus 3 and x plus 2, x minus 3. So you can see how the denominators are going to be the same at this point, which means I can easily just distribute. So 5x plus 10 plus 6x minus 3 over x minus 3, x plus 2. I can just distribute and combine, and I would get an answer. Does that make sense? Okay, so now let's do an example question from a previous SAT test. This one is quite easy, but let's look at it anyway. So you have 5 over x minus 1 plus 8 over 2 parentheses x minus 1. Which of the following expressions is equivalent to the one above where x does not equal to 1? So just a quick side note, the reason why they tell you x does not equal to 1 is because any number over 0 is like basically invalid. It's impossible. It's just against the rules of math. So this information is not necessarily helpful for you solving the question, but it is like a good thing to know, because if you put 1 here, then you would get 1 over 1, which is 0. So that wouldn't make sense. Anyway, now trying to solve this question, let's do what we were doing earlier. Okay, so what we were doing earlier was we were trying to multiply the denominator here with the denominator there, right? So that we can get the same denominator at some point. But what we notice here, okay, this is pretty easy, because 8 over 2 parentheses x minus 1, that tells me, hey, I can just simplify this. So I could just get 5x minus 1 plus 8 over 2 is just 4 over x minus 1. Now this becomes super easy because now I made the denominators the same. You want to be, for some reason, a lot of people find this difficult and they don't notice that there's like a 2 here. You want to be a bit creative. Like you could have done the technique that I was doing earlier, where I would like go through and multiply it all, and it would be very the bigger hassle, but in this case, just notice that 8 over 2 is 4. So 4 over x minus 1, then you just get 9 over x minus 1, and the answer is A. Alright, thank you, bye.